If you go out to your backyard and just start digging, how far could you get before you hit the center of the Earth? We have carved out some impressive spaces relatively close to the surface. Deep underground, beneath layers of soil and hard rock, physicists have built massive chambers to research dark matter and neutrinos. But pushing deeper than those labs introduces an immediate, brutal physical barrier. For every single kilometer you descend through the crust, the ambient temperature rises by about 25 degrees Celsius. During the Cold War, the Soviet Union launched a subterranean space race to see how far they could push past that heat. They built the Kola Super Deep Borehole, a massive industrial project designed to pierce the pressurized rock. They spent 20 years grinding downward, but at 12.2 kilometers, the drill hit a physical wall. The rock at that depth was so hot it behaved like gooey plastic. Every time they tried to drill further, the hole would simply collapse in on itself. This is the deepest human beings have ever gone, but compared to the 6,400 kilometers required to reach the dead center of the planet, that record-breaking hole barely scratches the surface. We are physically locked out of 99.8% of our own planet. Our engineering simply melts. So how do we know exactly what is going on down there if we cannot actually go look? This seismographer reading shows the raw data geologists used to solve that problem. They realized they didn't need to dig, they just needed to listen. Every time an earthquake hits, it acts like a massive planetary sonogram, sending distinct ripples of energy deep into the ground. These ripples behave exactly like sound waves, and they come in two main varieties: P waves and S waves. S waves have a very specific physical limitation. They easily travel through solid rock, but the moment they hit a liquid, they completely dissipate. When scientists placed detectors all over the globe, they noticed a strange pattern. An earthquake on one side of the planet produced a massive blank spot on the exact opposite side. Absolutely no S waves were arriving there. The math left only one possible conclusion. For a shadow that large to exist, the waves had to be slamming into a vast, impenetrable barrier of liquid deep inside the Earth. By carefully measuring the empty space where waves failed to arrive, scientists mapped out the outer core, a sprawling subterranean ocean of boiling liquid metal. But that liquid ocean was not the final layer. When researchers looked even deeper, right at the absolute center of the planet, the seismic data started acting weird again. The waves passing directly through the dead center weren't traveling smoothly through a liquid. Instead, they were sharply bending and bouncing back. This distinct reflection meant there had to be something else hiding inside that liquid soup. A secondary, entirely solid metal ball, which creates a serious physics problem. We know the temperature at the center of the Earth is roughly as hot as the surface of the sun. Iron melts at far lower temperatures. The answer comes down to gravity. Sitting 6,400 kilometers straight down, the pressure is 3.6 million times stronger than it is on the surface. That immense weight physically forces the iron atoms together, locking them in place so tightly that they literally cannot melt. Those faint seismic echoes revealed an environment completely alien to our surface-level intuition, a solid iron sphere encased in boiling liquid metal. So we know the Earth is arranged in these distinct metallic layers, but why did it organize itself this way in the first place? Billions of years ago, young Earth was entirely molten. It was a completely chaotic, churning magma ocean. Over time, gravity sorted everything by density. The heaviest materials, primarily iron, sank all the way to the bottom to form the core, while the lighter, rocky minerals floated to the top to form the crust we live on today. This ancient sorting process built an engine. The intense heat radiating from the solid inner core acts like a massive stove burner. It boils the liquid outer core directly above it, driving enormous, sluggish convection currents. As millions of tons of liquid iron constantly stir and churn, they generate massive electrical currents deep underground. Those electrical currents project outward, wrapping the entire Earth in a powerful magnetic field. And we know this engine has been running for eons because its output is literally recorded in the rocks. As magma erupts and cools into basalt on the ocean floor, it permanently freezes the alignment of the magnetic field at that exact moment, leaving a readable barcode of the core's activity over millions of years. By decoding the invisible waves bouncing beneath our feet, We mapped an isolated environment we can never physically visit. That crushing, completely unreachable iron center actively projects the immense magnetic shield that sustains all life on the surface.